All right. Welcome everybody to our AAPG PSG monthly webinar. Today we have Dr. Mark Gordon, and let me introduce him to you and then I'll hand it over. Before I get too far ahead though, you might see a little Q&A box at the bottom of your screen or somewhere around there. If you have a question during the talk, feel free to type that in there. And then towards the end of the talk, we'll go back and answer those. If you need to ask your question vocally, just type that into the box. I can unmute you and you should be able to ask that. All right. So Dr. Mark Gordon, he graduated from the University of Texas at Austin with a PhD in geological services under William R. Mohlberger. He did postdoctoral research at the University of Paris 6, now Sorbonne University, with Jacques Anglais and Paul Hancock. He also did research at Rice University with Hans Avelamont, working on Paleostress analysis in Honduras, and at UT Austin with Paul Mann in Cuba. Since 1997, he has been working in the oil and gas industry with GX Technology, Repsol, Shell, PGS, and Baselip Fronlob in Asia, or Baselip Fronlob Asia. And with that, I will go ahead and hand it over to Mark. I will mute myself and turn the video off. Just let me know if you need anything along the way. I'll be here.
Okay, thank you. Thank you for the introduction and thank you for attending this talk. I was asked to give this talk by the organizing committee, and one of the reasons was because I was one of the few people from North America who attended the International Geomechanics Symposium in Abu Dhabi last year. So this is my talk from that meeting with very slight modification. And so it's a Cenozoic brittle deformation in Central Arabian plate, implications for the tectonics of the Middle East. And my co-authors on this are Jacques Anglais and Paul Hancock. Unfortunately, both of them are deceased. And this is actually rather old data that I'm showing. Paul Hancock started working in Arabia in the 1970s, and he had several Saudi students work with him at Bristol, and they published from the 1970s and into the 1980s. And Paul Hancock, of course, was an expert on joints, and so he was working on joints along this Central Arabian graben system, and he and his students defined most of the graben and did field work along it. And most of the base work for the area was done by Paul Hancock. Well, he and Jacques got to know each other, and they had this Perry Tethys program that was run out of Paris, but had numerous international researchers involved with it, mostly in Europe. And one of the projects was they decided would be Saudi Arabia, and Paul had invited Jacques to come down to Saudi Arabia and study the faulting along the Central Arabian graben, which he had noted, but he was aware of the Anglais technique. He had read many of his papers, and they had even collaborated on a book. Jacques wrote a major chapter in a book that Paul edited. So he was a natural fit. And then I was doing I was in Paris as a visiting research scientist, and Jacques decided that this would be the project that I'd work on, would be to collect more data in more areas than they had done. And so I was working with them on this project. So as I mentioned, this is to promote the International Geomechanics Symposium. So I went to it last year, and this year it will be in Al Khobar, Saudi Arabia, which is right next to the causeway that goes to Bahrain. It's near where the major oil fields of Saudi Arabia are. And the abstract deadline is in a week. And we are trying to encourage more people from North America to send in abstracts for this. It's very international meeting. I believe last year they said they had 36 countries represented. A couple hundred people show up and all are geomechanicists and structural geologists, so and well, engineers. So it's very much focused on geomechanics, but it's still there's a broad range of subjects that people work on, and so there's many of you would be able to submit an abstract, and if you got 5 of you together, you could even have a session, probably. So one of the draws for me would be the chance to go out in the field, and as you see, the exposure is very good. So we had a pre-conference field trip led by Abdul Wahad Nufal of ADNOC, and it was a very well organized field trip. It was a very accessible area. You see, this is a nicely paved road, and you drive up. It's about 150 kilometers from Abu Dhabi city, and you drive up, and there's a large parking lot with these wonderful exposures of the Eocene Daman Formation. And you see, this is the field trip group. We all had these stylish blue vests, safety vests, of course. And here is a dextral fault. This is a large fault plane. And this fault continues down into the wadi below and is continuous. So it's a fairly large mesoscale fault. And they've studied all the fracture and faulting up here, and they had a very nice poster session at the outcrop explaining what they had seen in the area. So it was a very interesting field trip, a one-day trip. And there we go. Okay, so this it was held in the Hotel Sofitel, and it was a very nice facility. I'm sure that there will be an equally nice facility in Saudi Arabia. The meeting was held on 2 floors, and a lot of people stayed in the hotel. So the lunches were served downstairs, and were part of the registration fee. And there was this is the larger ballroom, that there were nice meeting rooms, but also nice not corridors, really, entryways, with which allowed for a lot of interaction, and they were always serving coffee. So nice food and drink service along the meeting, and a lot of time to interact with people and get to meet people from different places than you normally see. Now, the topics covered, I tried to write down what the major ones were. There's really a big variety. So drilling geomechanics, rock in-situ stress, reservoir geomechanics. So these are more engineering dominated field. And energy storage is a big subject. And as you can see in the outline in the previous slide, there's an emphasis on this energy storage at the upcoming meeting. Structural geomechanics and tectonics is where this talk fit into, and there were about 5 talks that were somewhat all different, but less on the engineering side, let's say. So hydraulic fracturing, carbon capture, utilization and storage. There were actually a couple sessions on that. Induced seismicity. This is somewhere where people, say from Texas or Canada, really could add to the meeting, because there wasn't that much there. There was a session, but it's something that's a big focus of the ARMA here in the US and in Canada, and we could see more of that. And also, interestingly enough, there was a series of talks on hydrogen, for example, hydrogen storage in salt caverns. Okay, back to the Central Arabian graben system. And I started in the title description, I described why we went to Saudi Arabia a little bit. But the academic interest is, are the Central Arabian structures related to motions on the boundaries of the Arabian plate? That'll be the next slide. And previous studies on the joints, a couple of publications by Hancock. And as I said, Paul Hancock wanted to go from joints to faults, and so that's why he recruited Jacques Angelier. And so we are using the techniques of Jacques Angelet, and I will get to that next soon. Okay, so the tectonic setting of the Arabian plate, maybe people aren't so familiar with it around here, but the major boundary to the north and partly to the east is the Bitlis Zagros suture zone. So the Bitlis is in Turkey and Zagros is in Iran, basically. And this is a continental collision between Arabia and Eurasia. Variously started between the various authors cite the initiation between the Eocene and the Miocene, but nearly everyone agrees that by 20 million years ago, the full thickness of the Arabian lithosphere was entering the collision zone. And that creates a lot of folds and faulting and has led to the expulsion of Anatolia as continental escape along the East Anatolian Fault and the North Anatolian Fault. We also have the Dead Sea transform connecting the Red Sea to the Bitlis Zagros suture. And the Red Sea and Gulf of Aden have been opening as oceanic spreading centers, Gulf of Aden for longer and Red Sea maybe since 5 or 3 million years, again, depending on what source you use. So where we're working is in the green box. In fact, the area that we mostly worked went from about here to about here. So it wasn't along the entire length. Paul Hancock had done studies along the entire length and combined it with the literature review. So the Central Arabian graben complex goes from near the Kuwait border, in fact, right along the Kuwait border, into Central Arabia. Riyadh is about here. I'll be showing that later. And then Wadi Nisah is here, it forms the southern portion of it. And yeah. Okay, so wrapping up the events that are seen in the area, that Bitlis Zagros suture zone experienced ophiolite abduction in the late Cretaceous. The actual collision occurred in the Eocene to Oligocene. The Oligocene to present, you have the Red Sea Gulf of Aden opening and the Dead Sea transform faulting occurring. Now, the rocks that we're working on, several formations, starting in the Middle Jurassic, Druma Tuwaiq Mountain Formation, which happens to be the major source rock for the Arabian oil fields, at least the Mesozoic ones, I should say. There's also a Paleozoic system. The Hanifa Formation, Jubalia Formation. Arab Formation is a very buggy carbonate, and it is the reservoir rock for the major oil fields. The Hit anhydrite, if you ever wondered why the Arabian oil fields are so great, well, you have a great source rock, a great reservoir, and a great seal, which is the anhydrite. And so we didn't actually work on that. But one problem with anhydrite, of course, being evaporite, is it could dissolve. And there are places where there's dissolution features, and these are highly chaotic. We did work on these formations, which are above it and subject to falling into the dissolution features. But where we studied them, they're right along major fault zones, and they are very coherent. So we don't believe that dissolution was the cause for the structures that we found. Very importantly, we did some work on the Daman formation, and that's Eocene. And since we found all of the tectonic phases in that formation, in that case, it dates the deformation to be post-Eocene. So a bit about the Angelet method. Some people may be familiar with this, and there are other people who've done similar methods. But what we're using is we take the silicon side lineations, for example, here, and invert for regional stress. So you need to have the strike and the dip of the fault plane, the rake of the silicon side lineations. Let's say it's 60 degrees here. I think this is an oblique view, so it's actually, these are supposed to be pretty much down dip silicon sides. And the sense of slip, for example, the arrow showing here. So this is a normal fault. Okay, and so what we're trying to do is we invert these for the principal stress axes. So we're getting the orientations. You need more information if you want magnitudes. Okay, we use the programs of Jacques Angelier, as I said, but other programs are available. And here are the few of the principal references. The most important for the technique are the 1984 and 1990 references. This is a paper in the book by Paul Hancock, which goes through a general guide to his technique. Okay, so the directions that we come up with, the first phase was north-south extension. It appears to be a contemporaneous east-west tension. Then we have a northeast tension, a northwest tension, and a strike slip period, late strike slip, which is northwest compression and northeast tension. Here's a digital elevation model from the literature with our locations shown on it. So Khurais is one area that I'll be talking about. East Nisah, Hata. I'll be coming back to this. Riyadh is located here, so you see the graben sort of in circles. Riyadh or forms a half moon around Riyadh, so it goes up in here, and a couple of the other locations which I won't be showing today. So near Khurais, by the way, this is actually a 10 billion barrel oil field now, but it wasn't developed at the time. And this was our vehicle, as you see, hidden behind the rock. So this is much larger outcrop than you might think just looking at it. You know, it's like 10 meters high at least. And you might get the impression that it's not faulted, but actually you get in here and there are many small faults, say with a displacement of 10 centimeters or less. And so there were many slickensides to measure at this location. And as it's saying, this is what I'm showing here is the age of the rocks, not the age of the deformation. So the age of the deformation is post-Eocene. And we have this north-south tension as the first phase. And then we have a northeast tension followed by the northwest tension. So simplified on the terrain elevation model. So the Khurais sites are out in here. So there were several outcrops like the one that I showed, and we combined the data from all of them. And so the next site we moved to is the East Nisah site. This was the classic Nisah area, but I found many more faults out in this area, starting with this one. So this is a larger fault, and it is putting, it's a classic normal fault, putting younger rocks, the mid-Cretaceous Biad formation on top of the Wushayy formation. And as you see, the exposure is quite nice. And in the footwall, mostly in the Wushayy formation, I measured many faults. This is one of the faults measured in the area. And this is the slickensides sort of prof slickensides. And the satellites are indicating down dip slip. So this is clearly a normal fault, and you get bed offsets that also corroborate that. So these are the fault slip data from that area, what I'm calling the East Nisah. You see very prominent north-south tension, and then the northeast tension, and the finally actually a strike slip, the late strike slip with the northeast compression and the southeast tension or northwest tension going along here. One note about these strike slip faults, and you'll see this with a lot of the strike slip faults. One way we get chronology is overprinting slickensides, and we see that. Another indicator is when you have these strike slip faults and they have, say, the dip more typical of normal faults. This is like probably a 70-degree dip and maybe a 75, 80-degree dip here. So these are not pure vertical faults. This is an even lower dip, probably 60. And so they're reactivated normal faults. Just looking at the data, that's what you expect although we do have some vertical strike slip faults too, which is what you expect. You also, when you reactivate faults, you're more likely to get oblique slip. This is a paper going back to Bott 1961, talking about oblique slip faulting, which is part of the methodology. This would be, well, I won't get into that anyway. Okay, so another area, this is like Khurais. So Khurais and Hawtah are far off the graben, but they have similar deformation to what we see in the graben. And so it's showing that the graben is the big feature, but the deformation of Arabia was more pervasive and further from not just right on the graben, but elsewhere as well. So in the Hata area, we see normal faults such as this, the stylites indicating, normal faulting going down like that. And we also see this dextral fault with calcite scales is one way to see the census slip, and also the stylites, and sometimes you can use these buggy features as well. So the results from the Hata area are a north-south, a little bit more northwesterly tension, and nearly perpendicular east-west tension, and again, a late strike slip with this northwest compression and northeast tension. So the next area is the main Nisah site, which has a lot of faults. And this shows a north-south tension and east-west tension, which appear to be contemporaneous. And I forgot to mention the big star here is sigma 1, the 4-prong star is sigma 2, and the smaller 3-prong one is sigma 3. And we also have joint measurements, particularly here. These are poles to joint, so they should be in the sigma 3 area. And in fact, that is a sigma 3 symbol in there, but there's a lot of joints that fall right in it. Some of the tension gases and joints are significantly off. So they may either be another phase or they're just different timing, or anyway, they don't necessarily fit perfectly. So then we have a northeast tension at the Nisah graben, very well defined. And when we look at this and we see the Red Sea spreading, these are the GPS measurements. Now, these are recent, and we don't believe that these faults are recent. They're somewhat older. They're, yes, post-Eocene, but we also know that they don't affect the Quaternary. Paul Hancock and his students studied areas where supposedly the Quaternary was affected, and they didn't find any effect in the Quaternary. And there's even a upper Pliocene formation, which is not affected by the faulting. So we don't believe it's active, and obviously the GPS is giving the active deformation, but we see a similar direction to the Red Sea. So maybe early in the opening of the Red Sea, you had this deformation that affected Central Arabia as well. So then there is finally a northwest tension at the same site. And strike slip faulting from all the sites. You see we have two different phases of strike slip, but they're also at two different sites. So we didn't have overlapping relationship. However, in all cases, as I mentioned, it appears to be reactivated normal faults, and this is corroborated by the overprinting spiconite lineations. So to summarize, the post-Eocene Paleostress, so we are documenting post-Eocene Paleostress events in Central Arabia. And one point that Paul Hancock makes is that all these areas are at least 250 kilometers from the plate boundary. So it's a classic case of the foreland of the plate boundary being affected by the plate boundary. And so we are attributing the northeast tension to the opening of the Red Sea in the Miocene, and the northwest tension might be related to joints that Hancock had measured earlier in 1984. And we don't really know what forms the northeast tension and southeast compression from strike-slip faults. We just see strike-slip faults affecting later. So there's a chance for small deformations affecting the Arabian plate, possibly related to renewed deformation along the plate boundaries, but we don't understand very well why, or actually even what time these formed at. And I mentioned earlier that the joints in faulting do not affect the Paleopleistocene deposits or the Quaternion alluvial fans, based on the work of Paul Hancock and his students. And I would like to acknowledge the King Abdulaziz City of Science and Technology, which was our sponsor in Saudi Arabia. And also, as I mentioned earlier, this was part of the Perry Tethys program being worked on out of Paris, but it was an international program to understand the overall, Europe, Africa, Africa, Arabia, Europe, Eurasia convergence, which has been going on for a long time. So there are many different types of studies that it supported. And our Saudi colleagues were Al-Qadi and Shat and Fahad Al-Tamali, who was in the field with me. So thank you very much. I realize it's a short talk, but as I said, this was a talk that was presented, that was supposed to be a 20-minute talk at the Geomechanics conference. So I haven't really made it a long talk. And I'm open to questions.
Awesome. Thank you so much, Mark. That was great. Hey, we don't mind a short talk. I totally understand those conference talks. And it was great to kind of hear about IGS. I really wanted to go last year, but it wasn't in the books, but great to kind of see that field trip and all of the people that were there. If anybody has a question, feel free to type it into the Q&A box. You can also raise your hand. I have a participant list and I can unmute you if you want to talk and ask your question. Or we can utilize the chat as well if need be. Okay, question came in. This is from Clinton Tippett. Can you comment on how these structural relationships relate to the oil and gas fields in the region? It's a good question.
Well, yeah, that's a good question. And actually, from Caxt, they were asking me that too. And the reason we went to the Hata area was that they wanted to understand the fracturing, because although at the surface there, you only have the Mesozoic rocks, the Hata area is an area with some Paleozoic oil fields, which have been discovered, but have not, well, at the time, certainly had not been developed. I think even now they may not have been developed. And so the angle we put on is that the fractures at the surface should continue at depth. So hopefully we don't have the subsurface data. Now there is a thesis from Rice University with one of Peter Vale's students, a Saudi student. And so he shows some north-south faults, and those go through the oil field. So combining the surface with the subsurface there can be of interest for the fractures and how they control the reservoirs. At Khurais, so we have all this normal faulting at the surface. That is a major oil field right there. So again, how does the faulting at the surface occur at depth, and you know, that now that field has been developed, as I don't expect there to cause any problems with compartmentalization. This is a problem we commonly see, of course, in our oil fields, but I don't think that's a problem in the Saudi fields. So in Hancock's paper, he discusses somewhat the formation of the oil fields, and the formation of the oil fields, now if you go, they are closer to the coast than where we were. So actually, if we go to that slide, let's see if we can, it's yeah, I don't have that. I want to, no, we're in the wrong direction. So, oh, that would have done it. Yeah, okay. So actually, let's go back up to the first one. All right, so the major Mesozoic oil fields of Saudi Arabia are relatively close to the coast. Guar is right about here. And so the oil fields formed as structures, probably related to the collision. Now, when you get to the, okay, so when we're down here at Hata, which is down here, the seismic data shown by Peter Bale's student does not show any salt. So the Mesozoic is just resting on the Permian. And there's not a décollement there or anything. However, you do have the Hormuz salt, which is known out in the Arabian Gulf. So the speculation is maybe under the oil fields, you have the salt and it's affecting the deformation and causing the formation of the structures. But the timing would be pretty much the same as the timing for the graben or the timing at Khurais. And so, I mean, you do have some information, but if you're looking for one-to-one information from our work to the oil fields, well, we haven't made it. But you know, definitely the Saudis were interested in what we could contribute and how they've used Paul Hancock's work, or now our work. I'm not sure. I really don't know because I'm not in touch with Aramco.
All right. Awesome. We had a nice comment from Mario Hernandez. Nice to listen to a student of the great Paul Hancock. Thank you very much.
Okay, I wasn't exactly a student, but I was. If you want to say that I was a postdoctoral student, you could say that. So, but it was one really great thing about this work I'd like to mention was it was a chance for me to meet Paul Hancock. He had been a reviewer on our papers earlier. And, you know, I knew about him very well, read all of his papers. And by doing this work, I actually had the chance to meet him before he passed. So that was very wonderful. And went out to dinner with him with our wives. And so it was very nice.
Another question. This one comes from Jim Tucker. You related a lot of the graben to Red Sea spreading. Given that this area is very distal Zagros foreland, did you see wrenching along the arcuate trace of the overall graben system? Borehole breakouts in eastern Arabia, east of this area, indicate current Zagros-oriented compression. Thanks.
Yeah. So, all right. When this is also mentioned by Paul Hancock, is that if you see this and you think of, you know, like say pre-extension right here, and what you would predict would be, you know, like strike slip here, dextral, strike slip here, sinistral, and you don't see that. You see normal faults. And so you go up here, Wadi al-Batin is the Saudi Arabia Kuwait boundary, actually. And there's not, it's more, still more normal faulting, although it's hard, you're talking about features that are like 10 meters high. So it's sort of hard to say for sure. Now, Paul Hancock is, okay, so first of all, the Red Sea would be the second phase, and the first phase would be that north-south tension, east-west tension. that's observed about here. And Paul Hancock's original thought was, oh, well, that's related to the ophiolite abduction in the late Cretaceous. The timing is not well enough, so you could say that it's not. But we saw the same deformation at Khurais. So we think that instead it is indeed the first phase, but it's an early phase. And so what it's showing is that there is some tension in the foreland, even though there is compression, certainly compression in the Zagros, but as Jim is saying, compression over here near the coast with the borehole breakouts. That compression may be contributing to the strike slip faults that I see, because they're very late strike slip faults. So basically, my explanation would only be that you had multiple phases which ended. And so, yes, we are attributing that extension to the Red Sea, which is more distal than the Zagros, actually. But that's a phase that ended. And then the only event that would be correlatable perhaps to the borehole breakouts seen in the oil fields would be that late strike slip. So, which is a much later phase. So that's really my only answer to that.
Awesome.
Thanks for the question, Jim. And thanks for your knowledge about Saudi Arabia. Jim worked in Saudi Arabia for many years, so he's very knowledgeable.
Nice. Another question from Clinton Tippett. Can you explain the sinistral movement sense on the Dead Sea transform? Its orientation would seem to make it dextral if it is part of the collision.
Well, it's very well known that the Dead Sea's transform is sinistral. And basically, Arabia is moving north faster than what is shown on this figure by these authors, Wushayy and others. The Sinai block is moving slower. Basically, and the GPS corroborates that, is that that Arabia is moving north or faster than the Mediterranean blocks are, and so that makes it sinistral.
Okay. Yeah, that's a good observation. And then another question from Clinton: is the protuberance of the Arabian shield a structural feature? And if so, might there be a link to the structures that occur directly to the east?
Well, it's definitely a structural feature, but it's Precambrian. So there is a feature that I didn't get into, and this is known as the Centro-Arabian Arch. And again, this is in the work by Paul Hancock. And right where the Centro-Arabian Arch turns, you have the Nisah graben. And so, yes, it does seem to, and also most authors who've worked, not just Hancock, but most authors who've worked on this, do believe that the Centro-Arabian graben is due to basement faulting. So the faults that cut the basement were reactivated and formed the Centro-Arabian graben. And that seems, that seismic data that I mentioned from Peter Bale's student seems to corroborate that. So yes, it does have a role. I'm not sure if that satisfies Clinton or not, but.
Awesome, thank you so much. Another question just popped in from Alina. Are the Pliocene flood basalts affected by the brittle deformation in the Arabia plate?
So probably, but we haven't visited these areas, so we haven't done studies on this. Paul and Jacques went over here because there was a recent earthquake, but obviously that's related to the Dead Sea transform. It's not the basalts in the interior, such as these basalts and stuff. But we never extended this study to go to these areas. We only worked in the Mesozoic rocks and the tertiary rocks in Khurais. So I don't have an answer for you, but that's a possible area of study, by the way, is to see what's happening with the basalts and see if they're fractured. There are also a lot of basalts that are closer to the Red Sea, and there are very prominent normal faults along the Red Sea, and quite a bit of uplift or exhumation, if you prefer, but it's really uplift because they were in the Cretaceous, they were at sea level. So these mountains along here, the Red Sea hills, they're actually quite high. So there's active normal faulting for sure. And how much the flood basalts are affected, I don't really know. Can't tell you. Didn't work on it.
Okay. Cool. Good questions. Another one by Michelangelo. Is it possible the extensional deformation of the CAG could be due to east-northeast, west-southwest compression caused by Red Sea ridge push and Zagros collision?
Yeah, somebody has proposed it. I can tell you that much. So my view of ridge push is that if you go to the Mid-Atlantic ridge and go like 2,000 kilometers on each side, there's a lot of ridge push, because what ridge push really is the slope that is when you have a mid-ocean ridge, which is elevated, and the sides which are aging and are subsiding, that's really the push. And so when you have a small ocean basin, I don't see there being much push. That's my view. There'd be more push from the Gulf of Aden. That has been proposed, but I don't believe that the ridge push is really driving it. I see it, as extension related to strike slip faulting. What's really driving the Arabian plate is, there could be remnant slab pull from the collision. That's what's driving the India plate too. The ridge push would have more of an effect on the India plate, of course, but that's the best I can say.
Okay, cool. Yeah, good questions. That might be it. There was a question. I missed some of the presentation. Is it saved and possible to watch later? And yes, give us about a week or 2 weeks. We'll put this on YouTube. I will post the link on our LinkedIn page, or you can find our YouTube page, AAPG PSGD, and search the authors or the title of the presentation, and hopefully you can find it that way, or just send us an email. We can send you the link when it's ready. And I think that's it. I don't have any more questions on the Q&A. I don't see anything in the chat, and no hands are raised. So if no more questions come in, we thank you, Mark. We really appreciate the talk and
use the extra time to write your abstract for the IGS in Saudi Arabia.
Yes. Abstracts are due in 1 week for the IGS, so we'd love to see some more PSGD folks on there. Jim.
Okay, well, thanks for the invitation.
You're welcome. Thanks for being here today.
Okay. You're welcome. All right, bye.